This is SpaceTime Series 27, Episode 68, for broadcast on the 5th of June 2024. Coming up on SpaceTime, more evidence that Venus is volcanically active, discovery of a new kind of volcanic eruption on Earth, and the maiden flight for the new Ariane 6 rocket now slated for next month. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new analysis of data from NASA's Magellan radar identified two volcanoes on the mysterious world of Venus that appear to have erupted in the early 1990s. The new discovery adds to last year's detection of what appears to be a different Venusian volcanic eruption, also in Magellan data. The new study analysed archival data from NASA's Magellan mission to reveal surface changes indicating the formation of new rock and lava flows linked to volcanoes that erupted while the spacecraft was in orbit around the planet. Managed by NASA's Jet Propulsion Laboratory in Pasadena, California, the Magellan spacecraft mapped some 98% of the Venusian surface between 1990 and 1992, and the images it generated back then remained the most detailed of Venus ever undertaken. The study's lead author, David Volcanic from the Annunzio University, says that by using these maps as a guide, the new results show that Venus may be far more volcanically active than previously thought. By analysing the lava flows, Volcanic and colleagues observed volcanic activity on Venus in two locations, which was comparable to that often seen on Earth. The new findings build on the historic 2023 discovery of images from Magellan's synthetic aperture radar that revealed changes to a vent associated with the volcano Mat Mons near the Venusian equator. Those radar images proved to be the first direct evidence of a recent volcanic eruption on Venus. By comparing Magellan radar images over time, the authors of the 2023 study spotted changes caused by the outflow of molten rock from Venus's subsurface, filling the vent's crater and spilling down the vent slopes. Scientists study active volcanoes to understand how planets' interiors can shape their crust, drive their evolution, and of course affect their habitability. The discovery of recent volcanism on Venus provides a valuable insight into the planet's history and why it's undertaken such a different evolutionary path compared to the Earth. For this new study, which has been reported in the journal Nature Astronomy, the authors focused on archival data from Magellan's synthetic aperture radar. Radio waves sent by the radar travel through Venus's thick cloud cover, then bounce off the planet's surface and return back to the spacecraft. It's a process called backscatter, and these reflected radar signals carry information about the rocky surface material they encounter. The two locations studied were the volcano Sif Mons in Estella Reggio and the western part of Niobe Planitia, which is home to numerous volcanic features. By analysing the backscatter data received from both locations in 1990 and again in 1992, the authors found that the radar signal strength had increased along certain paths during the later orbits. These changes suggested the formation of new rock, most likely solidified lava from volcanic activity that occurred during that 2-year period. But the authors also considered other possibilities, such as the presence of micro-dunes formed from windblown sand and atmospheric effects that could interfere with radio signals. To help confirm new rock, the researchers then analysed Magellan's altimetry data in order to determine the slope of the topography and locate obstacles that lava would flow around. The authors interpret these signals as flows along slopes or volcanic plains that can deviate like fluid around obstacles such as shield volcanoes. And after ruling out other possibilities, the team concluded that these were, in fact, they had to be new lava flows. Using lava flows on Earth as a comparison, the authors estimate the new rock which was emplaced at both locations would have been between 3 and 20 metres deep on average. They also estimate that the Sif Mons eruption would have produced around 30 square kilometres of rock. Now, that's enough to fill 36,000 Olympic-sized swimming pools. And the Niobe Planitia eruption produced some 45 square kilometres of rock. That would have filled some 54,000 Olympic-sized pools. Now, as a comparison, the 2022 eruption of Mauna Loa in Hawaii, that's Earth's largest active volcano, produced a lava flow with enough material to fill 100,000 Olympic-sized swimming pools. These new results, in tandem with the earlier discovery of present-day geologic activity, increases the excitement in the planetary science community for future missions to Venus. NASA's upcoming Venus Emissivity Radio Science Instar Topography and Spectroscopy, or VERITAS mission, is slated to launch early next decade, using state-of-the-art synthetic aperture radars to create three-dimensional global maps and near-infrared spectrometers to figure out what Venus's surface is made of, while also tracking volcanic activity. The spacecraft will also measure the planet's gravitational field in order to determine its internal structure. Venus is a fascinating place. As well as being Earth's nearest planetary neighbour, Venus is often considered to be Earth's sister planet. That's because both are the same size, with similar masses and diameters. Both were formed under similar conditions out of the same material in the same part of the solar system and at the same time. However, if Venus is Earth's sister planet, then it's somewhat of a twisted sister with a massive runaway greenhouse effect. In fact, Soviet and American probes have revealed Venus to be the closest thing to hell in our solar system. Its surface is scorchingly hot, with an average temperature of 462 degrees Celsius. Now that's hot enough to melt lead. And those thick, opaque, planet-shrouding clouds, well, they do cause rain, but the rain isn't water, but rather droplets of metal-eating sulfuric acid. Scientists have seen what looks like snow caps on some of Venus's taller mountain ranges. But it turns out that snow isn't frozen water ice, it's actually metallic. And the clouds on Venus are so heavy, they quite literally crush Venus's carbon dioxide-rich atmosphere, acting very much like the lid of a pressure cooker, and giving the planet a surface pressure some 92 times greater than the average sea level surface pressure on Earth. From the little we've seen, the surface of Venus is dominated by well over 1,600 volcanic structures, and that's more than any other planet in the solar system. The surface is 90% basalt and consists of a mosaic of volcanic lava plains showing evidence of regular periodic resurfacing by floods of lava. Now, all this indicates volcanism has played a major role in shaping the planet's surface. In fact, Venus may have had a major global restructuring event about 500 million years ago. That's based on the low density of impact craters on its surface. Venus has shield volcanoes, widespread lava flows, unusual volcanoes called pancake domes, and arachnoid or tick-like structures called scallop margin domes, which have never been seen on Earth. Now, interestingly, there is no evidence of any plate tectonic activity on Venus, which raises the question, how does the planet's internal heat dissipate? Being closer to the Sun than the Earth, Venus orbits our local star every 224.7 Earth days. But amazingly, Venus rotates in retrograde compared to most of the other planets in our solar system. In other words, the Sun rises in the west and sets in the east. Exactly what caused this retrograde rotation remains somewhat of a mystery. Also mysterious is how slowly Venus rotates on its axis. A Venusian day lasts some 243 Earth days. That means a Venusian day is actually longer than a Venusian year. The thing is, it's hard to find out much about the Venusian surface. Russia have sent numerous spacecraft to the surface of Venus, but they've all had a tough time surviving. The first few were crushed and cooked in the Venusian atmosphere long before even reaching the ground. Now, eventually, Russia finally built a probe that made it all the way down to the surface intact. The problem is it wasn't able to send back much data because its equipment, including the camera lens, had literally melted by the time it touched down. Finally, one Russian probe did make it all the way down to the surface and survived long enough to send back just a few tantalizing seconds of data and images. What scientists saw was a parched world, bathed in a half-yellow light by the thick cloud cover, a surface covered with jagged slabs of maroon-coloured rocks baked over the eons to create a desertscape periodically resurfaced by volcanism. It was these adverse conditions of the Venusian surface for humans which caused the focus of planetary missions to shift to Mars, which is further away from the Sun and a lot cooler. This is space-time. Still to come, discovery of a new kind of volcanism on Earth, and the maiden flight for the new Ariane 6 rocket now slated for next month. All that and more still to come on SpaceTime. Scientists have discovered what they're describing as a new kind of volcanic eruption on Earth. A report in the journal Nature Geoscience claims the Kilauea volcano erupted like a stomp rocket in 2018, something geologists had never seen before. Of course, no two volcanic eruptions are exactly the same, but scientists think a series of explosive eruptions on Kilauea volcano fit into a whole new category. By analysing the dynamics of the 12 back-to-back explosions that happened in 2018, researchers describe a new type of volcanic eruption mechanism. The explosions were driven by sudden pressure increases as the ground collapsed, and that blasted plumes of rock fragments and hot gas into the air. The string of explosions on the summit of Kilauea were part of a sequence of events which included lava flows erupting from lower on the flank of the volcano. Those lava flows destroyed thousands of homes and displaced residents on the island of Hawaii for months. Understanding exactly what happened in past volcanic eruptions, colloquially called hindcasting, allows volcanologists to make better forecasts about future eruptions and gives more accurate warnings to people about an eruption's path. For the most part, explosive volcanic eruptions are either primarily driven by rising magma, vaporized groundwater, or some combination of the two. But one of this study's authors, Josh Crozier from the University of Oregon, says these eruptions didn't quite fit the mold. He says the eruptions don't seem to have involved either rising magma or vaporized groundwater. The eruptive material contained very little that looked like fresh magma that had just been blasted out. There was also no evidence for significant groundwater being involved. The Hawaiian Volcano Observatory, part of the US Geological Survey, keeps close tabs on Kilauea. The volcano is covered in seismic instruments, ranging from ground sensors that measure the shaking of the Earth to tools that analyze the gases released from the volcano. University of Oregon volcanologist Leif Karlstrom says this sequence of eruptions were all remarkably similar and unusual. Putting the data into a variety of atmospheric and subsurface models, the authors pieced together a new story about what happened on Kilauea during the string of events in 2018. It seems before each explosion at the summit, magma was slowly draining from an underground reservoir. This magma was feeding lava flows 40 kilometers away, over on the eastern flank of the volcano. As the reservoir became depleted, the ground above it, the crater within the caldera at the volcano's summit, suddenly collapsed, and that quickly increased the pressure in the reservoir. And because there was now a pocket of accumulated magmatic gas sitting at the top of the volcano in this reservoir, the pressure increase squeezed magmatic gas and bits of rubble through a conduit and then blasted them out through a vent in Kilauea's crater. The researchers compared the eruption dynamics to a stomp rocket toy, where stepping on an airbag connected to a hose launches a projectile into the air. Crozier says the stomp in this case was this kilometre-thick chunk of rock dropping down, pressurising the pocket and then forcing the material out, while the rocket part of the game was the gas and rocks erupting from the volcano. Now, mind you, caldera collapse is fairly common, so while this is the first time scientists have specifically spelled out this particular stomp rocket mechanism, it's probably not the only time it's happened. The study was able to link geophysical observations to properties of the volcanic plume in the atmosphere. The research points to new ways to observe eruptions and combine sensor measurements with computer simulations to better assess hazards and eruptions. The fact that this was a series of smaller eruptions may have made it easier to see the underlying mechanism. That's because other complex processes won't overshadowing the stomp rocket component. This is SpaceTime. Still to come, the maiden flight of the European Space Agency's new Ariane 6 rocket, now slated for next month, and later in the science report, a new study shows that vaccines are still our best shot at staying safe from the latest strain of bird flu. All that and more still to come on SpaceTime. The European Space Agency has formally announced that the inaugural flight of its new Ariane 6 launch vehicle will now likely take place during the first 2 weeks of July. The announcement follows the successful completion of the latest review of the Ariane 6 launch system, including more than 4 weeks of intensive tests of both the rocket's main core and upper stage, as well as its 2 strap-on solid rocket boosters, and the new launch pad and ground support systems, which have been built especially for it at the Kourou spaceport in French Guiana. The extensive series of tests have included launch simulations which saw the removal of the mobile gantry, the chill down of ground and launcher fluidic systems, the filling of both the upper and core stage tanks with liquid hydrogen and liquid oxygen, and the successful ignition of the Vulcan 2.1 engine thrust chamber. Other tests saw the Vulcan 2.1 engine fired for a planned 4 seconds and then switched off, with its liquid oxygen and liquid hydrogen fuels then being drained to their separate underground tanks. That exercise showed how the system can be kept safe in the event of a launch abort. There was also a nighttime full-scale wet dress rehearsal for the Ariane 6. That was completed in October when the rocket was again fueled and then drained of its fuel. And in the following month, November, a full-scale rehearsal was conducted in preparation for its maiden flight, going through the complete launch sequence countdown, followed by a 7-minute full firing of the core stage's engine. That 7 minutes is the planned ascent burn time. A third combined test loading in December included a launch countdown to qualify the launch system in degraded conditions and ensure its robustness in preparation for operations. This sequence included qualification tests of several launch system functions, just in case of a mission abort, and it also included yet another ignition of the Vulcan 2.1 engine thrust chamber. It was the 5th countdown run to include loading Ariane 6 with cryogenic propellant since July. Then in January this year, the cryogenic connection system passed its final test, with the liftoff disconnection operations lines and umbilicals going through their paces. ESA boss Josef Aschenbacher says the announcement of the launch date follows successful completion of all dress rehearsals and performance goals. So, where to from here? Well, later this month, a final Ariane 6 launch system qualification review will be held. That'll be followed by the integration of the payload onto its adapter and then the fitting of the fairings. Another full wet dress rehearsal slated for June the 18th, with the Ariane 6 again fueled on the launch pad and subsequently drained of fuel in preparation for pre-launch. It's been a long road to get the Ariane 6 launch vehicle to this stage. The rocket was initially planned to fly back in 2020, but then the COVID-19 pandemic hit, and there were also repeated technical issues which have kept it grounded longer than expected. The Ariane 6's predecessor, the Ariane 5, blasted off for the last time in July last year. That was after some 27 years of service, flying no less than 117 times between 1996 and 2023. And with a smaller Vega C rocket also grounded following a launch failure in December 2022, and of course Russia still being boycotted by Western sanctions over Russia's invasion of Ukraine, Europe has for the last few years lacked an independent heavy-lift means of access to space. The payload for this inaugural Ariane 6 flight will come from 9 different countries and dozens of organizations. They include a number of small satellites, ranging from established science bodies like NASA through to university student spacecraft. Included are probes to measure gamma rays, track wildlife, test self-healing solar cells, confirm the theory of blackbody radiation, undertake smart farming observations, demonstrate a new radio beacon system, and carry quantum-based sensor measurements to study the Earth's magnetic field along the launch trajectory. The payload includes 4 CubeSat deployers which will release spacecraft away from the Ariane 6 upper stage. These will include 2 re-entry capsules and 9 orbital spacecraft, all set to be deployed at altitudes of around 600 kilometres. CubeSat deployers are like mini launchers, orchestrating a series of spring-loaded ejections to shoot satellites at the right time, at the right speed, and in the right direction. There are also multiple experiments which are designed to remain attached to the rocket's payload adapter. This report from ESA TV.
Now, the upper and main stages of the Ariane 6 flight model have arrived in French Guiana, and their integration is complete. Together, they form the central core and are ready to be moved into their vertical launch position.
The mechanical integration of the launcher has started a couple of weeks ago when we have finalized the qualification of the launcher, of the launch base and of the launch system. And we had also reached the approvals for moving the core central on the launch zone.
After the horizontal integration of the core stages, the rocket is transported to the massive mobile building for a further vertical integration. To do this, the central core is transported by 4 automated guided vehicles, 2 at the back and 2 on front.
It's an automatic guided vehicle. And that vehicle actually moves towards the launch pad completely by its own. It is guided by magnetic stripes that are in the road until the magnetic stripe stops and it finds itself in front of the launch pad.
During these transport procedures, the automated system also protects the integrity of the central core, ensuring no torque or stress is put on the assembly. With the rocket in its vertical position, its 2 solid propellant boosters will be added.
So the boosters, we can use them in 2 configurations. We have 2 boosters or 4 boosters. This is a modular configuration for Ariane 6. For the inaugural launch of Ariane 6, we will use 2 boosters because of the configuration of the payloads under the fairing. And so to propulse them outside the gravity of Earth, we need only 2 boosters.
After this, fluid and electrical lines will be connected, and then all that remains are the passengers added to the upper part. As the summer slowly approaches, it is clear Ariane 6 is on track to soon fly for the first time.
And in that report from ESA TV, we heard from Eileen Ducati, ESA's Ariane 6 launch system dependability and safety lead, and Tina Baukner da Costa, ESA's Ariane 6 launch system engineer. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that the vaccines we have for bird flu are really our best shot at staying safe if a strain of the virus starts spreading between humans. A report in the journal Human Vaccines and Immunotherapeutics warns that human cases of avian influenza are starting to pop up sporadically around the world. So, researchers have been reviewing existing studies on vaccines for the most concerning strains of the virus in order to examine how safe and effective what we already have really is. Looking at studies in both humans and animals, scientists say current inactivated vaccines are a safe and affordable option. They say while live attenuated influenza vaccines may be even more effective, they require more research into their safety. Other newer types of vaccines in development include mRNA vaccines and virus-like particle vaccines, both of which are showing promise. The authors say vaccination remains humanity's best defense if bird flu becomes a bigger threat. So it's important to keep investigating a diverse range of vaccine options. Avian influenza or bird flu was detected last month on an egg farm in Victoria's West. Testing eventually revealed the strain was H7N3. Agriculture Victoria says the property has been placed into quarantine, all the birds have been destroyed, and authorities are on the ground to carry out further investigations. While experts are relieved that this strain wasn't the highly pathogenic H5N1 strain, that strain has been detected overseas, and poultry keepers are now being urged to monitor their flocks very carefully. A new study has found that the popular kids at school tend to get less sleep than the rest of the student body. A report in the journal Frontiers in Sleep showed that popular teens tend to sleep 27 minutes less per night than their peers. The study also found that popular girls tend to experience more insomnia symptoms than boys. The researchers asked a sample of over 1,300 Swedish teenagers to nominate up to 3 friends. Those who received the most nominations were defined as more popular. They found that the teenagers defined as most popular tended to sleep less than their peers. They also observed that their findings were similar to previous studies which had been undertaken prior to the introduction of smartphones. And that suggests that phones aren't the reason that popular teens are sleeping less. The authors speculate that more friends may mean more time dedicated to them, which could result in less time left for sleeping. Of course, more emotional investment could also lead to sleeping difficulties, but more research is needed. A new study suggests that early feathered dinosaurs may have had two different types of skin. A report in the journal Nature Communications claims that the dinosaur Psittacosaurus had reptile-like scales on most of its body, but with feather-specific skin only on the feathered section of its tail. Paleontologists analysed skin samples from fossilised Psittacosaurus, which lived around 130 million years ago, and which only had feathers on its tail. They found that the skin cells on the rest of the body showed similar structures to those found in living reptiles today, but are very different from the skin on today's birds. The authors say that developing two kinds of skin in this way may have allowed the dinosaurs to retain the protective functions of the reptilian skin while also experimenting with the early stages of feathered evolution. Well, it seems to be an ongoing theme this year, but once again there are growing concerns about the level of inaccurate information coming out of artificial intelligence programs. The level of fake data, often woke and sometimes dangerous, spewing out of AI is now forcing tech companies to spend billions of dollars to try and fix the problem. The idea of simply sacking the woke staff who are programming garbage in, garbage out hasn't dawned on them yet. So what it means, put simply, is that AI can't be trusted. It lies and it makes stuff up to cover that dishonesty. While some experts think it's all fixable, many others don't. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, as we spoke about last week, the AI overviews were giving very strange information, things like running with scissors is okay and putting non-toxic glue on pizza to make sure the cheese sticks, which came from this Reddit post from
your mouth. Don't do that.
Yeah. Google has given Reddit $60 million so that it could data mine all of its years-long databases, and most of which is good information. But, of course, some of the unusual posts have popped up, and Google Gemini has sort of assigned that a higher ranking because it was from Reddit. Now, Google has obviously started to remove some of these ridiculous results, like eating rocks is good for you or the pizza and glue stuff, which is obviously wrong. And, look, Google has begun to manually delete these results. But, look, it just simply shows that regurgitating information from the internet without the ability to genuinely reason like a human could as to whether or not this information is safe is a problem. And we do see AI having a range of reasoning capabilities, but clearly it hasn't reached artificial general intelligence level yet. With the artificial general intelligence push, I did come across a very interesting tweet from Grady Booch. He's the IBM chief scientist of software engineering. And in a post on X, large language models are one of the worst genre of software products I've seen in my career. So that's a very bold statement. He says that they are inherently and irredeemably unreliable narrators, offering tantalizingly coherent output that is dangerous in its ability to deceive, threatening in its casual toxic bias, distracting in its being a huge opportunity cost that sucks all the oxygen from the air for many other needs, insatiable in its energy costs, and operating at an unconstrained global scale and largely controlled by a very small number of companies, such that there is little opportunity for meaningful accountability. And wow, I mean, he's right on the money there, because we do see AI sucking all of the venture capital money up, and we also see at the same time these crazy results from ChatGPT and these hallucinations. I mean, we're all worried that it's going to turn into Skynet and seek to destroy us, or to make us into slaves or mindless bots that just sit with folded hands.
Now, Sam Altman's realised there are problems with AI as well.
Well, he has rushed to form a new AI safety team, which he is the head of, with a couple of open AI board members, and this committee will make recommendations on critical safety and security decisions for open AI projects and operations. And the first task, he says, will be to evaluate and further develop open AI's processes and safeguards and present those findings to the board.
So this could mean hasta la vista, baby.
Well, it certainly could. I mean, he's obviously trying to avoid AI going bad because, he's staking his reputation and hundreds of of billions of dollars on this becoming, the next big thing. And he also is trying to get AGI, this artificial general intelligence, happening. And there's reports that GPT version 5 is currently in training. We just had the GPT 4.0 launch, and it is quite amazing how much better it is than ChatGPT 4 and, of course, 3.5 before it. But, part of his rush to head, not just to assign somebody, but to be the head of this AI safety team is because the OpenAI co-founder and chief scientist Ilya Sutskever, who was one of the people that sacked Sam Altman so spectacularly in November last year, and Sam Altman came back a week later, which is, a bit unusual, but he basically was worried that Sam Altman wasn't telling the truth. But the other big thing is that Jan Leakey, who was co-head of the AI super alignment team, which basically is the team that is heading up AI safety, both Ilya Sutskever and Jan Leakey have quit. And interestingly, Jan Leakey has now joined competitor Anthropic, who's received billions of dollars from both Amazon and Google. I mean, Google has its own AI, so this Anthropic is a competitor to Google, but also a big competitor to ChatGPT, and he's joined them to continue the super alignment mission and head up their super alignment team. So at least he didn't stay out of a job for too long, and he was complaining that he wasn't getting the compute resources from OpenAI to really nail down this AI safety problem, and he's defected. Well, he's left and he's gone to join another company. We don't want to wake up in a few years or a few months and Skynet has taken over the world.
That's Alex Zaharov-Reut from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.